Okay. Oh, wait. We are going to. Oops, no, not this one. There we go. Oops, someone.
That's me.
I was going to say. Let's leave a book up here. Timing today, we're going to talk about creating your architecture and design document. Pick my glasses up off the floor. And that should get us to a point where hopefully I can give you a break before the class break. Then we'll talk about part 3 of Peopleware and Webster 4, which is about metrics, and we'll be done for the day. That should give you more time for all this. Software architecture is actually one of the thorniest subjects in software engineering, mostly because there's a fair amount, I don't want to say disagreement, but there's a lot of sort of hand-waving that tends to go around architecture. Stop and think about it. Civil architecture has been around for several thousand years. And materials we use to build things, sand, stone, mortar, brick, cement, metal, wood, have had some advances, but they have not changed. It's you have these materials and you have the law of physics, and there is a vast body stretching back for, like I said, literally millennia on civil architecture. Software architecture is about 50 years old, and it's often more noted in the absence than its active practice. I would love to teach a class simply on software architecture. Instead, you're going to get like 3 slides on this presentation today. Keep that in mind and just doing your own architecture. The point of software architecture is trying to determine, get your arms around what you're going to build, and figure out the consequences of the choices. You know, what's important, what's going to happen, what am I using, what are my materials, how do things have to work, and what will achieve what I want to do. In my experience, having acted as a software architect on several times and having mentored, this actually often involves a lot of thinking. When I was at Monitor Labs, I worked there for a year, great little company. They built data acquisition boxes, these little boxes that would sit on top of smokestacks and have chemical sensors. And they'd monitor emissions and would collect data and then transmit this back to the company itself. And the company used this to monitor what pollutants and other emissions they had coming out, be able to report to the EPA, so on and so forth. And when I joined them, they had a number of such devices already, you know, they were marketing, but they were doing a whole new set using modern technology, by which they meant instead of these, say, Fairchild F8 processors that had 256 bytes of RAM, we were migrating to the 6502, which had a 64K RAM space and, you know, was an actual true 8-bit processor and so on. And I was chief architect. And this started, I'd been there about 6 months, so I'd actually already been doing debugging and fixes for existing products and understood the technology and so on. So when it came time, you know, I was working with Guy Grotke, the other programmer there, and we were going to do this. He and I talked some things over, made some basic decisions. We knew it was going to be 6502. We knew how much RAM and how much ROM we were going to have there. He and I were both fans of Forth. How many of you ever programmed in Forth? It's a stack-oriented language, and has the advantage that you can. It's a threaded stack-oriented language, which means that you can modify the environment from software very easily. So it's great for compact environment, great for embedded systems. Anyway. No. No, it's actually quite different. It's like, how many of you have ever used an HP calculator, stack-oriented calculator? Okay, it's like programming one of those, except with the ability to thread back and redefine terms and so on.
So like BC on, or is it DC on Linux?
I'm not familiar with that, but anyway, so I had to architect. So you know what I did? For 3 weeks, I sat like this in my office. We actually had acoustic tiles. I sat and stared at the acoustic tiles with my feet up on my chest, or up on my desk for 3 weeks, running through everything that I knew it had to do and the possible consequences and the problems we would run into, and just basically thinking deeply for 3 weeks. Now, what made this somewhat amusing was that I actually had 2 managers. There was Steve Goldberg, who was one of the company founders. He was the chief technical officer, brilliant guy, great guy. And so technically I reported to him, but I also had sort of a line manager over me who was not technical at all. And he walked, you know, like the first day I was doing it, he walked by and said, "What are you doing?" I said, "Oh, I'm thinking, I'm coming up with the architecture." For 3 weeks, at least once a day, he would walk by and glare at me. Because I wasn't writing, I wasn't furiously typing on anything. I was thinking, I was trying to figure out, what are we going to have to do? You know, it's a constrained environment, it's going to have to do this, it's got to do this, we have this stuff, and so on. And after 3 weeks, I straightened up, put my feet on the floor, pulled out a graph pad, and started sketching out the architecture, all the various aspects of it. The point of architecture is to see as far as you can. It's basically to try and short-circuit armor. You try to do that discovery process in your head. And go down the paths and say, no, that's not going to work because of this, or that's just not going to work because of this, or we have this constraint or whatever. And you're trying, as you say, you're trying to come up with a coherent, organized approach that's going to meet your needs. Yes?
How did that affect your relationship with management?
I didn't care. We got it done, shipped the product, and then I quit to join a software startup. He wasn't happy when I quit either, so maybe, I'm not sure what the exact...
I think he was just perpetually unhappy.
I think he was too, actually. So you want to come up with a fundamental organization of the system. Just a second. It has to be grounded in the user's needs and requirements. Is this meeting? And in some cases that may be market needs, that may be constraints that are put onto you by, say, the hardware, the platform you're working on, and so on. And you need to prioritize and select the principles to build it. Yes?
So you're saying you're doing all the work in your head. Doesn't that have the prerequisite that your head contains all the information?
No, because well, my head contained a lot of information. I've been working there for 6 months. I knew stuff. If I needed to research stuff, I'd research stuff. Other times I've done architecture. I've spent a lot of time drawing. I'll see if I can find, I still have my 3 architecture documents for pages. It was 3 diagrams on large graph paper. One was all the subsystems and their connections. One was the class hierarchy, the fundamental class hierarchy, which was replicated across itself. And one was the structure, the object composition structure of a document. And I drew each of those probably a dozen times. Colored pens, large graph paper, and finally got it down to sort of like this sort of, it wasn't necessarily complete, but it was sufficient that as I would hire engineers, I'd go down to Kinko's, make 3 big color copies of these, hand them to the engineer and say, this is what we're building. That was our roadmap. You have to, fundamental structure, environment of the solution, what are your materials, what is your location, in other words, what's your platform, what are your tools? You're making decisions like that, and the constraints and opportunities due to those choices. And on top of all this, in doing architecture, you have to get everyone to agree with you, or at least go along. Tom Affinito. I went back when Apple was still trying, this is before they bought Next, they were trying to do their own They had a failed internal second generation operating system. And then they did this joint project with HP and I think IBM to do an object-oriented operating system. I attended the developers workshop for it. It was actually very well done, except it was all in C++, and it was just they just kept tripping over inheritance issues. Anyway, but talking about architecture there, Tom Affinito said architecture is ultimately a political issue. If you want to be a good software architect, you have to get along with people. You have to rally people to your vision. You have to listen to their feedback and either address their concerns or modify. This is one of the most intensely interactive in terms of interacting with people. One of the most intensely sociological aspects of software development is coming up with an architecture. Oops. Some definitions of software architecture. These are from, I have about half a dozen texts on the subject. To be architectural, that is for a document or deliverable to be architectural, it's to be the most abstract depiction of the system that allows you to reason about critical requirements and will act as constraints on all your subsequent refinements. You say architecture, simple say, some of you have already done diagrams. Well, here's the user side, here's the server side, here's the database they're both talking to, we've got this, you've got the user there. That can be architecture. On the other hand, you'd be surprised, as I've said, how many times companies proceed without that level. As I've already talked about when I went into AirRink, they had diagrams for the subsystems and they didn't fit. Literally, the interfaces that each one showed did not fully and correctly mesh with each other. And I had to basically draw a big circle around it, come up with an architecture that encompassed those subsystems, and then redo the design for the subsystems so that they all talk to each other within the context of the architecture. Sean Garland, another book on software architecture. The architecture defines that system in terms of computational components and interactions among your components. This is typically your 10,000 or 30,000 foot block diagram for the system. Shows a correspondence between the system requirements and elements of the constructed system. So your architecture needs to be defined by your requirements, and you should be able, for any requirement, you should be able to say, that gets done here, and point to a place on your architecture. If you can't, then you've left something out. And then clarify structural and semantic differences among components and interactions. In other words, particularly if you're using third-party products, if you're integrating with legacy systems and so on, you're going to have to say, okay, this system expects this and this, but we're doing this. This is how we translate across. Yes?
So what tools can you use to map requirements to your architecture?
Don't try.
Okay.
Just just simply manually go through. This gets back to the whole requirements traceability matrix, which was a big idea back in the 90s and is almost always proved unworkable. Don't use a tool. Sit down with your requirements and go through each one of them with your architecture document there and say, is this requirement addressed?
Okay.
You can actually do that as a human being in a relatively short period of time. You can do it as a team. You can do it as an individual. If there's questions, get the right people involved. Here is, and I've gone back and forth, what do I want you to have for your architecture? I don't want a big document. There's not enough time here. You guys don't have 3 months to think about the architecture of what you're doing, which would be ideal. You've got a week. Part of a week, actually. I'll go away. So, a top-level design. Partition, you should have a top-level design that basically encompasses what it is you're building, shows the major subcomponents, shows the interactions between them. Don't overthink this. This is your typical, here's client, here's server, here's database, here's this, here's user interface, and so on. but be sure to capture anything that is specific or unique to what you were doing. The how is that you're going to have to, and this is where your billable hours this week are going to be, is you're going to have to sit down individually and together, go over your requirements document and say, what does this mean for the architecture? And this is where you start getting the, do we have the right performance? Do we have the right tools? You know, what do we do to have response time? Try to flush out things that you might not have thought of but that are incumbent in it. Again, having done a professional desktop publishing system, the two things that 25 years later leap out at me are first, the difficulty of getting a sufficiently fast response from the time someone hits a key to when the letter appears on the screen. Keeping in mind that this, of course, is reformatting itself in real time. It's not just a letter appears. A letter appears and it may flow over, and it may hyphenate, and it may do this, or it may go to another page. It's about 1/10 of a second. That's more than 1/10 of a second, users will complain. The other thing was footnotes. Footnotes were a nightmare. Footnotes, like, oh yeah, you just do footnotes. No, trust me. If you're trying to actually automate footnotes and have them correctly position themselves, it's a nightmare. Doesn't seem like it should be. Seems like it should be very easy, but we lost probably a couple months on footnotes. Yeah.
So my dad worked at IBM when they did WordPerfect, or he worked at WordPerfect.
Oh, yeah.
And they did footnotes, and they did 1 million hours of user testing before they shipped. After they shipped, they had millions of users using it and had many more testing. And someone came back to them and said, "There's a bug. You can't have a footnote that's larger than 250 pages."
And my answer would be, you're right.
But they wanted a footnote that was longer than 250 pages, so they had to redo stuff.
Yeah, trust me, that's the world of commercial software, and I've been there too, so yes. It's like, you want what?
That made my heart hurt.
And the third thing about your software architecture, and this is something that just comes with time and experience, is that you want it to grow. You want to have the right stuff in place so when a nifty idea occurs to you, hey, we could do this. You look at the architecture and you say, oh, no, we can't. Or yes, we can. I mean, I can point both things in pages. You know, remember my story with rotating headlines, which we had explicitly disallowed, and then the CEO said, why can't we have rotating headlines? Like, Larry, because we made that decision 1.5 years ago, and the architecture doesn't support it. On the other hand, when the web cropped up, it only took us 4 months to basically do web layout because the architecture was just sort of primed and ready for it. It's like, yeah, we just do this, and this, and bam, we've got the whole thing. So, what's your architecture to include? Conditions of customer delight. I recommend that you start the architecture portion of your architecture design saying, this is what will make our customer happy. Then have a high-level diagram that says, this is what we're going to build. Then a description that says, and this is how what we're going to build is going to make the customer happy. And then perhaps a short section that says, and this is why we chose X over Y. This is why we made these decisions. I'm not looking for something long. This is not a class on software architecture. If you have more than a page of text aside from whatever your high-level diagram is, you're probably doing too much. So that's what I'm. And I'll get these slides posted today. Cross my heart, hope to die. All the previous slides, and actually all the previous lectures are all posted, by the way. Now design. All right. Now you're doing specific solutions to implementing architecture. There are several approaches to design. One is saying, here's what we are and aren't going to do in implementing this architecture. In terms of, in our architecture, you know, we are going to use this engine. We aren't going to make use of this built-in library and environment. We are going to do this. We aren't going to do that. You're trying to bridge between your grand vision of architecture and what someone needs to start coding. One of the fallacies, facts and fallacies, one of the facts of, well, yeah, it's one of the other. One of the things Robert Glass brings up in the book you're going to read later in the class is that if the designer is not actually coding as well, it's easy for the designer to say, oh yeah, here's a design, and hand off something to coders that's not sufficiently detailed to code. What you want with design is something that you can take as a program and say, okay, I know now what I need to build. Doesn't mean you can't go back. Doesn't mean you can't ask more questions of who's doing design or who's doing architecture. But you want something so you can start working instead of sort of thrashing around. The reason you have architecture and then go to design is to try and have conceptual unity, as per Brooks, in what you're building. Your design elements that you may have to worry about are user experience, user interface, database design, data structure design, patterns and module interfaces. A deep interface, I assume almost everyone here, I assume frankly everyone here has ever programmed with an API. Okay? API says, here are the function calls, here's what to do. But there's also a deep interface. A deep interface is the one that says, you have to call this method first, and then you can call this method a certain number of times, and then when you're done, you have to call this third method. That's the deep interface, and not all APIs do a good job of documenting that. That's when you start scrounging at, Stack Overflow or whatever and say, how do I get this to do that? It's like, well, you have to call this, and if you called it with this value, then you have to call this, and then you do all your work by calling this repeatedly, and then you have to clean things up by calling this, and then you're all done. Yeah?
Sounds like dealing with files. Like, you have to open the file.
Oh, yeah.
You close the file.
Yep.
You do operations between that.
But APIs often work the same way. In other words, but you'll have, it won't be as clean. Files, it's actually pretty clean. I have to open it, read or write, close it. Okay, the APIs is kind of like, if you call this routine, you can't call this one. Or if you call this routine, then you can only call one of these two routines next. So it tends to be more complicated, and it's not always all well documented. Yes?
So the design document should be more implementation specific than the architecture?
Yes, the design document is basically a guideline to tell people how to implement the architecture, how to code the architecture. Yes? Do you have your hand up also?
Oh, I was just going to say, with APIs, definitely OAuth tokens follows that, what you were just describing.
Oh.
They are a pain in the butt.
Yep, they often are. There's a lot of badly designed APIs out in the industry. Yes?
So you're saying architecture is more independent of like the language or frameworks or dependencies?
Definitely.
Design kind of says this is actually what we've got.
There may be some stuff that floats back. For example, with pages, part of the architectural decision was, well, we're going to do this at least initially under next step, and we know we're using Objective-C and so on. So that influenced, for example, my fundamental class hierarchies, because I knew that everything was descending from a root object, therefore I could do certain things, so on and so forth. But architecture is more independent. Design is basically the guideline to implementation, saying this is how we're going to implement the architecture. Yes?
So is it like a continuum between architecture and design?
Oh, yeah. And actually, we're not going to make it before the break. So I'll just talk a little more, and we'll do it after the break. For anyone who's really serious about wanting to get into software architecture, this is absolutely the one book you should buy. The Art of Systems Architecture is now 3rd edition, Meyer and Rechten. I have, and frankly, it's a great book because it talks about system architecting in a variety of domains, not just computers. They talk about politics. Frankly, if you go back and look at what they talk about social architecting, you will find a description of a lot of the issues that have cropped up around Obamacare. they're all pretty much predicted here because you have the issues of, who wins, who loses, who benefits, who pays.
Do you want to begin?
It's called The Art of Systems Architecture. If you simply remember the title, you can do it. And this book would be worth the cost, if nothing else, for their Appendix A. It's kind of like the Armor Appendix. Their Appendix A is called Heuristics for Systems Level Architecting. And this is a collection that the authors have gathered over a period of years of, I don't know how many there are, a couple hundred heuristics, meaning pithy little maxims that act as a reality check when you're sitting down to architect and design a system. Let me give you some examples. Very start here. Performance, cost, and schedule cannot be specified independently. At least one of the three must depend upon the others. With few exceptions, schedule delays will be accepted grudgingly. Cost overruns will not, and with good reason. The time to completion is proportional to the ratio of the time spent to the time planned to date. The greater the ratio is, the longer the time to go. Relationships among elements are what give systems their added value. This is one I love. Efficiency is inversely proportional to universality. That's why reuse is so hard. The more universal something is, the less useful it is for any given application. The more efficient and beneficial something is for a given use, the less universal it is. My all-time favorite maximum here is, in architecting a new system, the important mistakes are made the first day. I've cited that in expert reports. In other words, it is often at the very start that there are assumptions made, mistakes made really, that lay the seeds for system failure before anything else happens. This is a question of why are we doing this? Should we do this? Should we do this way? Now, the deliverables for design are going to depend in part on the methodology you're using, or you can just draw cute little boxes. So, for your architecture and design document, purpose of your product, purpose of the document, brief, paragraph, maybe two. Overall view of your system architecture, again, high-level architecture design, and no more than a page of text, and it can be less than a page, talking about the things we talked about. The divisions, based on your approach and or your team, in terms of, say, your front-end versus back-end, data, database, design specifics. The implementation decisions that you've made as a result of the architecture. Details so that, in theory, you're spending a week on this, okay? Your team, so on and so forth. But in theory, you should be able to finish this document, distribute it to the team, and everyone will know what they're doing based on it. That's the theory. In practice, you're going to have a lot of conversations. Actually, even in theory, you're going to still have a lot of conversations. But that's what you're trying to do, is something that everyone agrees on, and so they know what they're doing. And my favorite, identify the hard problems up front. I would strongly urge you in this document to say, here are the 3, 4, 5 hardest problems that we are going to face doing this. And make sure everyone has a say and that you all agree on what those hard problems are. And as always, this is due Saturday by midnight, and we'll have, we're not going to have you go over in great detail, but we'll have each of you, again, come up. You can bring up your whatever your pretty diagram is. And then say, here's what we learned in the process of trying to put this together. Questions? Since we want to kill a few minutes here, let the masses out there get done before I send you out. Yes?
How do you practice architecting?
The architect.
Okay. So,
let
me restate. Is there a way to do this without making myself look like an idiot at work?
No, this is
Thank you for your honesty.
yeah. This is the classic good judgment comes from experience, and experience comes from bad judgment.
Awesome.
The point of architecture is thinking a lot about it. First, you have to code a lot. You have to be good at coding. And then you have to think about, okay, if I'm starting a new program, what do I now want to know? And once you've done this a number of times with a number of programs, you're going to develop a set of skills that say, okay, I've got, someone comes to me and says, Webster, I want you to do a game. It's like, okay, here are all the things I need to know. And I start listing constraints and issues. Do you want this? Do you want that? What about this? What about that? Because of my prior experience, if I don't know those things, I know that the things are going to trip me up. So what you want with architecture is to flush out as much of that ahead of time in a real-world situation. In your situation, you got a week, okay? On the other hand, you've been thinking, you sort of, and this is where actually it helps to have done the requirements and the chart ahead of the architecture, because you're going to say, we don't have time to mess around. We're doing this, it's going to look like this, we're going to do this. This is all we have time for. We've only got, 6 or 7 or 8 weeks left, however much time we have left here. Other questions? Yes?
So I've noticed we've talked a lot about designing things from an end user perspective. One of the things that an end user doesn't have perspective on is most of the back end.
Yep.
So how do you go about making sure that your architecture is good for that is on back end?
Well, that's where you start to get into sort of the abilities. What is the performance? What is the reliability? What is the flexibility? The back end is important in terms of if I have to serve up a response to the user within a certain period of time. And by the way, end user, there are applications that drive equipment. There are applications that basically simply act as services to other applications. In that case, that is your user. In other words, the system you're developing, the first thing you have to understand is, what's my output here? What am I interacting with? Is it equipment? Is it humans? Is it other programs? What is it they expect? What are the constraints that they need in terms of the response time, the precision of the data, pretty pictures? The reason why my whole software engineering career I've been fascinated with games is because I consider them the highest expression of software engineering. Not only do you drag in just about everything, I mean, you've got graphics, AI, database, representation, algorithms, performance, modeling, simulation, so on and so forth, but it has to be fun.
And run in real time.
Nothing worth, fun in real time too. Well, some games it's like move and then you wait for the move and so on. But it has to be fun. The Tabasco products didn't have an end user in the sense of someone interacting with it. It simply transmitted data via radio link to some other computer which logged it. But we had to ensure that we followed the proper format so that the software on the other end could correctly interpret the data. We had to ensure that our data rate for transmitting this information was at a sample rate that met EPA standards and so on. So that's, when I say end user, there's big quote marks around that. But the question is that will drive how you do your database design. In other words, if this is not a system that requires fast response time, then you can get away with a fairly low end or slow, or this is a good enough database architecture for it. On the other hand, if you're writing a mass multiplayer real-time game where you've got a million users online, database architecture becomes pretty critical. Because you're having to update that. So that will, the question, it's usually best in systems architecture and design is to start with the output and look at the constraints there and work backwards. And it sounds quiet out there. If there's, are there any other questions before you guys leave up? If not, let's take a 10-minute break. We'll go till 10 after. We'll start up again, take roll, and do the next 2 lectures.
This is why I
I'm making
It goes hard.
What's the limit?
Those clicking left.